Hey there, that's Horner, and we just want to go through this 2005 problem. So we've done this one a few times before. This one is good for a couple different units. But the first thing we need to do is it says the vertical position of an elevator is shown above. They want us to find the velocity versus time graph for this. The best way to do this is if we look, we see that there's a pretty constant slope from 0 all the way up to about 8 seconds. And if you find the value for that slope, it would be about 1.5 meters per second. So we're going to start that 1.5 right here, and we're going to make a straight line going all the way over to 8 seconds. Now we notice that we see that we have a decrease in the slope. Okay, so the slope isn't as big. And so what we'll do is on this one, we're going to do the same thing. We're going to go down to about 10, where that acceleration starts at about 8 and then it finishes at about 10. And then notice that at this point we don't have any speed at all. So the slope is absolutely flat at that 14 meter mark. So now we have just a very constant line along the axis there right at 0 until we get to 18, and then we see that we speed up now in the negative direction. The value that we need to start with is at 20, so we've got to figure out what is the slope of the line from 20 all the way down to 25. And if you do your math, you'll find out that the slope is about 2.4 meters per second, so probably somewhere around here. Remember, we've got to start at about 20, so we're going to start this line, and we notice that it's a pretty constant all the way over to about 25. And so now we need to draw that acceleration that exists here and comes down and then goes to about there. So that is the graph. You actually get 4 points for that graph as long as you have these 3 areas. So 1, 2, 3 areas. That is 3 of the points. And then you have to have the 2 parts that are accelerating, and that is the 4th point. So 1 point, 2 point, 3 point, and then 4 points. So they want to make sure you can find those accelerations first. All right, so now that we've done that part of the problem, let's go on. We're going to go down to calculate the average acceleration for the time period of 8 to 10 seconds. So this one is pretty easy to do. We just know that the acceleration average should be equal to the change in velocity all over the change in time. The change in velocity, we are stopping at 0. Our beginning is 1.5 meters per second, and we're going to divide that whole thing by 2, and you end up with an average acceleration from 0 to that 1.5 meters per second in that 2-second time period of 8 to 10 seconds of approximately negative 0.75 meters per second squared. If you remember the original graph, what we're doing is, there's our original graph. We're looking at the acceleration that happens right here. And so we're basically just finding the slope of that line is all we're doing. And then dividing it by that change in time. And because it's 8 to 10 seconds, it's 2. This next part says on the box that represents the elevator, draw a vector to represent the direction of its average acceleration. And so we're going to draw a vector pointing straight down, and this would be the average acceleration. So it's just making its way down. On the next part, they now want us to decide, since there's a passenger on this thing, it has a mass of 70 kilograms, calculate the apparent weight of the passenger at t equals 4 seconds. So let's go ahead and draw the passenger. So here's our passenger. We're going to draw a diagram. And then we know that we have going down in this direction, we really just have mg. And it says that calculate the apparent weight at 4 seconds. If you go back to your diagram, you'll see that they're moving at a constant speed, which means that the acceleration here should be about 0. Okay, so your acceleration here is basically 0 because we have a constant velocity. If we have a constant velocity, acceleration is 0, then the normal force going up should equal mg. And the normal force is really what we call the apparent weight. So that's kind of what we're looking for. is we want to know, what does the scale show? The scale always shows what that normal force would end up being. So for this one, because the sum of the forces is equal to 0, we can say that the normal force minus mg is equal to 0. And that just means that the normal force is equal to the mass times gravity of that person. The mass is 70 kilograms. We know gravity is 10. And so this person has a weight of 700 newtons, at least they think they do, when they're on the elevator as it's traveling at a constant speed in the downward direction. So that one really isn't too bad. And that is the end of the problem.